Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us now begin solving this step by step. Ease of ionization under acidic conditions refers to the ease of carbocation, oxocarbenium, carbenium, formation upon protonation and loss of water, i.e., the stability of the resulting carbocation. Step 1. Identify the carbocation formed upon ionization of each alcohol. Compound I, 9-fluorinol loss of OH gives the 9-fluorynyl cation. The 5-membered ring carbocation is flanked by 2 benzene rings. However, the geometry of fluorine forces the empty p orbital to be perpendicular to both aromatic pi systems, giving poor conjugation. The 9-fluorynyl cation is actually destabilized relative to a simple benzylic cation because the 2 aryl groups are locked in a geometry where the p orbital at C9 cannot overlap effectively with both arynes simultaneously, bridged, rigid planar system. The fluorinyl cation is antiaromatic, cyclopentadenyl cation character, 4 pi electrons in the 5-membered ring, making it highly unstable. Compound 2, xanthan 9-O loss of OH gives the xanthanyl cation, xanthyllium cation. The oxygen atom of the pyrene ring is directly conjugated with the empty carbocation center at C9 providing powerful lone pair donation, oxocarbenium stabilization, plus additional delocalization into both flanking benzene rings. The xanthyllium cation is exceptionally stable. It is a well-known, isoluble, highly colored cation. This gives compound to the greatest ease of ionization. Compound 3, dibenzosuberyl loss of OH gives the dibenzosuberyl, 5-dibenzo, A-D, cycloheptanyl, cation. The 7-membered ring allows the 2 benzene rings to adopt a geometry where the empty p orbital at C5 can conjugate with both arynes. The carbocation is stabilized by homoaromatic bis-homoarene overlap and normal bis-benzylic conjugation. It is more stable than the fluorinyl cation, no antromaticity, but less stable than the xanthyllium cation, no heteroatom lone pair donation. Step 2. Rank the carbocation stabilities is equal to ease of ionization. Xanthyllium 2-dibenzosuberyl 3-fluorinyl I. 2 is most stable due to oxygen lone pair donation, oxocarbenium plus extended conjugation. 3 is intermediate, bisbenzylic stabilization, flexible geometry, no destabilizing antromaticity. I is least stable. The 9-fluorynyl cation is antiaromatic, 4n-pi, n is equal to 1, in the 5-membered ring, making ionization most difficult. Step 3. Match 2 answer choices. Decreasing order of ease of ionization to 3I option C. Why other options fail? A. I3-2 wrong places the antiaromatic fluorinyl cation as most stable, which is incorrect. B. I2-3 same error, also ignores oxocarbenium stabilization of 2. D. 2I3 wrong order for I and 3, fluorinyl cation is less stable than dibenzosuberyl cation. Therefore, the correct answer is C. Therefore, the correct answer is option C.